Another topic we're going to discuss that is incredibly important in any programming language, but also R, because there are some tasks that we would like to do that are conditional on other pieces of information, as well as tasks that we would like to repeat, of which are conditional on other information, or we want to just repeat something a known number of times. Um, these concepts are known as logical control. That is, you'll notice so far in just scrolling through all of the commands we've written here so far that everything is happening in a very linear fashion. So in a very practical setting, when we're working with data analysis, yeah, we want some things to occur in a very linear fashion from top to bottom, but there's other things that we want to accomplish that we only want to have happen only under specific types of situations, dependent on the value of certain variables, or whether or not something is true about our data, or we just want to apply something in a continuous fashion to all of our pieces of data. So having the knowledge of how to work logically, not only just in a linear fashion of writing our commands, but in a nonlinear way, meaning how to execute certain commands based on the values of certain variables and whatnot, is an incredibly important skill. So there's two major types of logical control that we commonly use. The first type is what's known as a conditional statement, which we often refer to this as the if-else statement, where we want to perform some type of execution where a variable or some statement, just in more general terms, is true. And if it's not true, we want to execute a different type of a collection of commands. On the other hand, our other type of statements are what are referred to as loops. And there's a few different types of loops, but the two dominant ones, at least in R, are the while loops and the for loops. So we'll talk a little bit about these. So let's first talk about the if statement. And before we do, we should actually have a discussion on something known as logical statements. So a logical statement is something that we basically ask the computer, and the computer gives us either a yes or no, and more specifically, a true or false response. And usually, logical statements break down into a few different types of inquiries. The most fundamental one are two things equal to each other. So suppose that I store the value of 5 in X. What I want to do is be able to check what the value of X actually is. So what I can do is ask the computer, is X equal to 5? Now, we obviously know it is because we specifically set it equal to 5. But in more practical scenarios, we may not know whether or not it's equal to 5. So as you can see, that is going to give us a value of true. If we wanted to ask, is X not equal to 5? This should give us a value of false, because it is false that X is not equal to 5. That sounds confusing. Just break the statement down. X is equal to 5. So if we say that X is not equal to 5, well, obviously that's not true. Put differently, it's a false statement, which we should, of course, get false. We have other comparisons that we like to do. For example, we may want to see if it's bigger than 5, less than 5, bigger than or equal to 5, or less than or equal to 5. And you'll see for each of these scenarios that it returns the proper output. X is certainly not strictly bigger than 5, and it's certainly not strictly less than 5. But these are true because we've put the equal sign there as well. So when it comes to comparing statements, Usually these are the fundamental types of relations that we look at. By the way, we can also do this for textual information. And we may ask other questions like, is y equal to the text? We should expect it to give us an answer in the affirmative, which interestingly enough, it does not, because we didn't set it equal to. Now it is. Okay. Do the same with text. We can also say, let's see. I wanted to do another one for substrings, but this is a little more complicated that I don't want to get into at the moment. But anyway, the point is that this mechanism of comparison allows us to control things in our execution. So the most fundamental one is an if-else statement. So for example, I may check if x is bigger than 2. Okay, the way we write this is in a block, and a block is specified by the braces here. We open the block with a left brace, and we close the block with an end brace. You can position these anywhere you want to, but it's common convention to put the open brace on the same line as the if statement. So what we're saying to R here is that if whatever value is stored in 2, we're going to run this set of commands, which is to print the statement, the current value is bigger than 2. But on the other hand, you know, we specify the opposite case by writing else, and the same deal with a block. We then write we'll run the commands. The current value is not bigger than 2. In other words, it's less than 2. So let's see what R does in this situation. And where did I mess up here? R sometimes requires you to put the else by the brace. I don't know why this is the case, but it does. So as you can see, it did not execute this, but it did execute this because our inquiry was true, that x was bigger than 2. Now, on the other hand, if we were to change the value of x to, let's say, 1, and rerun those commands there, now you can see the other command is being executed there, which is that the current value is not bigger than 2. So the if-else statements allow us to control the flow of execution of these different commands. We can write them in a variety of different ways, but that's the basics of it. On the other hand, we may find ourselves in situations where we want to repeat the same command over and over and over again for either a fixed number of times or until some condition holds true or does not hold true. So suppose, for example, that I just want to simply print out the numbers from 1 to 10. I can do this by using the for statement, doing the parentheses. And then basically what I do is I specify what's called an index variable. It's also known as an iteration variable. You can call it whatever name you want to. I'm going to call it just I in this case, but you can use whatever name you want to. And I'm going to use the in command. And then I'm going to specify a vector of values. In this case, the vector of values I'm going to specify is the sequence from 1 to 10 by every 1. There's a shorthand way of doing this, which is to write 1:10, and that's equivalent, if you run that, you'll see that's equivalent to writing the seq commands with the 1, 10, 1. So what this is going to do is set the I equal to 1, execute whatever is in its block, and then it's going to go back up to the top when it gets down here, go back up to the top, set I equal to 2, or whatever is in the vector, the next value in the vector, and run this command, et cetera, et cetera. So let's just say we want to just simply print the values. So here's what it's doing. It's going through in each iteration. It sets I equal to 1, and then prints out the value of I. Here's another example. Suppose I wanted to find the summation from 1 to 10. We can repeat this code, okay. We can create a variable called total summation and set it equal to 0. And then in each iteration, what we can do is take total summation and assign it to whatever value was in there and add whatever the value of I is. So if you think about this iteratively one at a time, it's going to set first I equal to 1. It's then going to take whatever value is in total summation, which is 0, add to whatever value is assigned to I, which in the first iteration is 1, and then store that value in total summation. It's then going to reach the end, go back up to the top, set I equal to 2, come down to here. 1 is now stored in here, and it's going to add that to 2, and you'll get a 3, and it'll store that in the same variable, and then go down to the end, and it will keep doing this. So just to illustrate the process, what I'm going to do is print out the value of total summation in each iteration, just so you can kind of see what's happening. Okay, and as you can see, the sum from 1 to 10 is 55, which using Gauss's formula, you know the sum from 1 to n is n times n plus 1 over 2, which in this case is 10 times 11 over 2, which naturally, of course, is 55. So we got the right answer, right? So that's the for loop. On the other hand, we may run into certain situations where we don't know how many iterations we're going to run ahead of time. By the way, let me run one more just so you can kind of see what we're doing here. You're always specifying a vector here, and the vector can be anything. It doesn't need to be numbers. It can be, and it doesn't need to be a vector. It can also be a list, by the way. But basically, what you're doing is specifying a list or a vector, and it's iterating at all values in that list or in that vector. So, for example, I could just look at all of the even numbers from 1 to 10, where we go, remember what this function does. It gives us a sequence from 2 to 10, starting at 2, ending at 10, and iterating by every 2. So 2, 4, 6, 8, 10, okay? And if you were to print these out, you'll see that you get just those numbers printed out. We copy and paste this. We're going to do something similar where we take the total summation and we add I to it, and then we print out what the total summation is. You'll see we should get something different than in the first time we did this because we're only iterating over the even numbers. That is, each iteration is going to set I first equal to this, then equal to this, then equal to this, and so on and so forth. So as you can see, it first sets it equal to 2, then it sets it equal to 4, 4 plus 2 is 6, sets it equal to 6, 6 and 6 is 12, and so on and so forth. The next thing we can do is what's called a while loop, where we do not know the number of iterations. Let me just check something. Let's see if this is correct. Oh no, wait. Read. Oh, I forget how to do the input. Just want to check one more thing before moving on and giving up on this. There we go, read line. So what we can do is basically keep going with this list, keep going with this loop until the value is 5, right? I'll just set it equal to 0. So while x is not equal to, let's say, 5, okay, what we can do is just keep repeating the same line over and over again until this condition is false. So right now, x is set equal to 0. And notice that this is not the same as the number 0. This is a string 0. Be careful with this. So here, what we're going to do is print out to the user, hey, input a number. We're going to read the line and get the input. And basically, we're just going to set that input equal to x, right? And we're just going to keep repeating this over and over again. We could say something like, your input was x. So what is this going to do? Hey, input a number. Let's say 1. Your input was 1. Input a number. Let's say 10. Your input was 10. You can also use strings, my input, right? But it's going to keep doing this no matter what I do. It's not going to stop until I put 5. Now it has stopped, because once you input 5, it's going to go back up here and run this condition. So the while loop is kind of like an if statement and a for loop put into one type of loop. So how do you know what to use? You use the while loop when you want to repeat something, but you don't know how many times it's going to run. It's going to stop with what we call a stopping condition, meaning it will keep running until something is true, whatever that something is that you specify. The for loop, on the other hand, will run only a fixed number of times because, well, that, you're specifying the number of times that it's going to run. All right, so those are the basics of loops. And by the way, you can combine the statements. So for example, what you could do is something like, okay, you can check in here, is x equal to 5? If it is, then print out the statement, you got the correct number. Otherwise, you're going to print out the statement, nope, try again, and get rid of those. So notice that when you run this now, nope, hey, nope, try again, nope, try again. But if I input 5, notice that it will change the output, and it won't do nope, try again. Okay, and notice it's not asking, hey, input a number, because it's not going back up to the top of the loop. Okay, so those are the fundamentals of loops and if statements. These are what we call the logical control statements. They're incredibly important to know for the purpose of doing our data analysis, because there are some scenarios where we need to have very fine control over how the commands are being ran. But that logical control is dependent on certain types of circumstances that we may not know ahead of time. So in the case of R, when we're working with our data, we may, we may want to do a simple searching algorithm where we're looking for a specific value in a data set, or we're looking for something to be true in the data set. Or we want to do something more sophisticated, like run a statistical estimation, but we want to do that over and over and over again for different models that we've specified. All of this can be done by leveraging conditional statements, so, logical flow, such as loops, for loops, while loops, and if statements. There are other ones, but we're not going to get into them. I'll leave that up to you to study on your own. But right now, you should try to get comfortable with the basic logical control that we've done here.